It just I thought it's a very cool question to put in. So first of all, this first question I want to go over is, oops, this one, yeah. So a lot of people didn't understand how do I approach this one, and I'm gonna tell you it's not as bad as you think. First of all, you have to understand the question. The question is saying, um, the question is saying if you have this, and they say if is 8 when x equal to a. Now, what it's saying is this. What it's saying is it's actually a coordinate because the input is a, the output is 8, and that is what it sums up to be. Got it? Now remember, there's three conditions to be continuous. First condition, fa must be defined. Is it defined now? It's now only defined. It told you it's 8. Right? Second condition is what? Limits x approach to a of f of x must be exist. Now I'm going to say limits as x approach to a of x squared minus a squared over x minus a. If I plug in, I'm going to get 0 over 0. So I'm going to get limits x approach to a of x plus a and x minus a. So that's end up to be 2a. But the third condition is usually 1 and 2 equal to each other. So it'd be limits x approach to a of f of x equal to f of a. So we know f of a is equal to 8. So 8 is equal to 2a. So a must be 4. That just asks the limit as x approach to that. Now, this is a very cool question. Now, for me, when I say cool, for me it's cool because I'm a nerdy kid. So I'm going to go to this part. I'm going to go to this graph. I'm going to highlight this, and I'm going to do this. So I'm going to show you what happened here. I'm going to show you in this mode. So let's just say a equal to 0, right? Is this function continuous? Yeah. Is it continuous? Pay attention. There's a hole, right? And then you say, wait, there's a hole. There's a hole at 0. But there's a hole, it's always at 0. Pay attention. If I move it a bit, if I move to 1, where's the hole at? It's no longer at 0 because here it's filled in already. So your hole shifted right one. It's not on the graph. It looks like continuous, but it's not continuous. What if x equal to 2? Is here is continuous? Yep. At 1 seems continuous. What happened at 2? The hole is moving. Is that pretty cool? The hole is moving along the line. Pay attention. Now this green dot is a solid dot. This dot is also moving accordingly. But funny thing is they are moving toward each other, right? So here, guess what? The hole is at 3. Now wait until they go to 4. So if I go to 4, what will happen? The function is continuous because the hole was right here, but the green dot fulfilled the hole. Is that pretty cool? You guys find out the solution of math. And also that's graphic understanding. I think that's more important than anything else to show you that graphic understanding. than anything else. This is what's the cool part about it. Now let's go to the other question. 67 is also another one. There is an equation like this. So this is 67. Now I play A and B here. There is only one chance that this three lines are connected. There was infinite amount of possibility. Infinite amount of possibility. Between negative 10 to 10. And more likely, you look at this, they're probably not going to connect. But the problem is I play the button at different time. If I play at different time, there's one chance that there's only one chance and one chance only. And this line, three lines are connected. So where's the breaking point? Where do they break? It happened at x equal to what? -1 and where? 3. Right? And then you're gonna say, okay, Lucas, if you're not here for 5 days and still not paying attention on the board, I don't know why you're here at all. I just don't see the valid point of that. Okay, so I'm gonna get rid of this. So obviously the breaking point is somewhere here and somewhere here. So I'm gonna say, well, limits as x approach to -1 from the left side. Which equation I'll be using? 2, right? Equal to limits x approach to -1 from the positive side. This is on the test, okay? It's what? Huh? Ax plus b, good. So what happened when limit x approaches -1 or 2? What's it gonna be? It's just 2, because there's no thing to plug in. The function is 2. You plug in, doesn't matter what value, you're always gonna get output of 2. That's on the test, by the way. It doesn't matter what number I plug in, it's always going to result equal to 2 because the y value is always equal to 2, doesn't matter what x value is. I'm going to say that again. That's going to be the easiest test question, and you guys are going to get it wrong. So that's 2 equal to ax, oh, a not a, this is 1 now. So it's going to be a plus b. Does that make sense? Now the second break point is happen at where? 3. From the left side of left side is going to be ax plus b equal to limits x approach to 3 from the positive side of -2. Is that okay? What are you going to get? 3a plus b is equal to -2. Now this is two equation system. So I can multiply this -3 because I wanted -3a here. Plus, actually minus what? 3b here is equal to -6, I think. Wait, did I do something wrong? This one's a -8, right? Oh, so I should multiply this by 3, sorry. This I should multiply by 3. True for the first one is positive. Can you move up? Move up because I can't really zoom any further. I mean, I can zoom more. That's good? Is that okay? If I multiply this by 3, I'm going to get 6 is equal to -3a minus 3b. So I'm going to put -3a, -3b is equal to 6. This is a system equation. They can cross it out now. -2b is equal to 4. B is equal to... Well, I feel like there's something wrong again. This should be positive, right?
Yeah, positive.
Okay, I make so many mistakes. Okay, so here it's going to be 4b equal to 4, b is equal to 1. Once b equal to 1, 2 equal to negative a plus 1. So I'm going to do minus 1 on both sides, so it's me 1 equal to negative a is equal to negative 1. So I got those two things here. Are you going to see this on the test? Absolutely. Matter of fact, it's probably going to be harder than this.
Mr. So you put the function on the side that you're going to.
What?
Like the ax plus b, it's on the right, the first one, because I'm going that way.
I'm going left to right, so
Yeah.
I'm going to start from the left side of the equations too.
Okay.
The right side equation is ax plus b. Now at 3, ax plus b becomes my left side of the equation. My right side equation becomes negative 2. I just plug in the value. Now if you find out this, what do we say? A is negative 1. And b is what? So only positive one possibility. And that's the answer. Questions? Is that okay for everybody? This is on the test. Okay, now next one. Oh, like this one? If limit x plus e on pi is equal to pi. This is on the test. It's why? Because if y value is pi, it doesn't matter what x value approaching. It's always pi. So think about that. That you have to understand those simple things. Another one, like on intermediate theorem value, I remember one of my teachers tricked me about this question. Or my calculus teacher tricked me. I got it wrong on this test. So immediately, if you plug in 0, what am I going to get? And if I plug in 4, is what? Did it go to 0? It did. But is intermediate value proving that there's a 0 between them?
Yeah.
Why not?
Because there's a discontinuity between the two.
There's actually not only discontinuity, there's a vertical asymptote. So since the function is not continuous at 2, and 2 is within this interval, guess what? It's invalid. It can possibly have a 0, but it's actually invalid due to from the understanding of intermediate value theorem. It actually tells you it's not true. It's not going to happen. It's not. It's the intermediate. You cannot use intermediate value theorem to prove that's true. Whether there's a 0 or not, that doesn't say that. It only says intermediate value theorem is no longer valid in the situation because the asymptote discontinuity is between the two endpoints. Does that make sense? Yes.
So you know there's an asymptote at 2.
You have denominator equal to 0. Got it? And there was a question, I think some people asked 94, right? The last one was x squared plus x. And they say it go through 6 or not. Did you do that one? Did it go through 6? The truth is yes. I will show you not only they go through 6, this is actually understand the proof right here. See, between 2.5 is right here. and at 4, it's gonna give you 6 and 6.667. It has to go do 6. And the discontinuity is outside of that endpoints. So it doesn't matter. It's still valid. The discontinuity happened outside of the endpoints. So it does not influence intermediate value theorem. Does that make sense? Now, if it's inside, then you can say it's not valid by using intermediate value theorem. It possibly have 0. But if you want to use intermediate value theorem to prove, you're going to say it's not possible to use intermediate value theorem to prove because it's not continuous. Does that make sense? Okay, those are the questions. Can I go to the next idea? Next idea is trig limits. Last year, this part is the worst part. I'm gonna say it again. I don't really care about your AP exam because your AP exam does not show you the understanding of calculus. And this is one example. It's never covered on AP exam, but it's always on UCF tests. To show you the proof that this actually happened is this. A few days ago, last week, I got a message from Madeline, not you. But the question looked like this. I don't know, Josh can see it. It looked like trig limits, right?
Yeah.
Okay, so he can tell you it's trig limit. So she sent me a message, Mr. Ye, how do I do this problem? And I have heard for last year. And this question is never tested on any AP exam. And then it's tested again in UCF. So what I'm trying to say is, I'm gonna say this so many times. I think AP Calculus is BS because it does not conclude the whole calculus as a whole. It's actually a dumbed down version of calculus. So I'm not gonna teach toward a dumbed down version. I'm gonna teach you the whole perspective calculus. I'm gonna say that over and over again. And this is a perfect example. This test question is on UCF, it's on Harvard, it's on MIT, it's on UF, but it's not on AP exam. And you're gonna see 3 major ideas is not on AP exam, and they're all super important. Trig limits. Actually 4. Trig limits, another one. Related rate, another one. Optimization, another one. Definition of integrals. The 4 concept here is like the most crucial part of the calculus, and each one should count for 10% of the calculus, but they are missing that. So AP calculus is diluted itself. So if you guys think you're getting 5 on my test and you can survive MIT, no. I'm gonna say no. You had to get an A in all my tests to survive MIT if you go into MIT or Harvard or Yale or any Ivy League. And even as much as UCF. There was a people getting 5 on Calc 1 before, and they take Calc 1 over again and UCF and they're getting F. Let's just tell you the perspective of AP Calculus doesn't really show you anything. Now for me, I'm not gonna do that. I'm gonna show you the whole calculus. So I'm gonna teach you trig limits, and I'm gonna ask you to evaluate all the trig limits, and this is what I'm gonna do. So limit x approach 0, I'm gonna put it on the test as well. Sine of x over x, that's always equal to 1. Now there's a proof for that, but I don't have time to prove for that. So it's actually using squeeze theorem. The second trig limit you need to know is 1 minus cosine of x over x is equal to 0. Now I will say this is the most popular one. The first one is the most popular one. If you make limit x approach 0, sine of x over x happen, that's good. it has to be sine of 1x over 1x. Or there's a corollary. How to spell corollary? Corollary. Something like this. I don't know how to spell. Somebody know how to spell?
Corollary?
Yeah.
C-O-R-O-L-L-A-R-Y.
Okay, C-O-R-O.
L-L-A-R-Y.
Yeah.
No, it's corollary. There's another R in there. Corollary?
Can somebody look it up, please?
Brad, you have the computer? I didn't hear.
Corollary. Like, which is what corollary?
Anyway. All right. I can't count on the only brown kid here. He can't spell anything.
No, it's corollary.
All right. So that means, and alternatively, that if sine x over x is equal to 1, that also tells me x over sine of x is equal to what? It should be what? Is 1. Why? Yeah, if you flip 1 over 1, right? You flip them, it's still 1 over 1. It's still 1, regardless of which way. So x over sine of x is also going to provide you 1, even though that's not one of the trig limits. It just, if you know this, you should know about this. It's just that kind of like transitive property, right? Like if this is true, this must be also true. Does that make sense? Now, another thing is, a lot of you guys don't understand this. X approach to 0. If you have same thing top and bottom, like say sine, it should have, I think write like this is very confusing. You should write like sine of ax over ax. Because if this both are the same, let's say 2x, let's say sine of 2x over 2x, this is going to 1 as well. And this is going to go 1. So I think it's better to write this way because it has to be something on something, top and bottom has to be the same thing. If they're the same thing, let's say sine of 5x over 5x, that's equal to 1. If limit x approaches 0. Does that make sense? Now, what I'm trying to say is, now we're going to produce a question. And this question is a little bit hard. So we're going to say sine of x equal approach 0. Tangent of 4x over let's say 9x here. Now I'm gonna say this. One of the first thing I will do is I will take the 9 outside the limits. Because 9 is 10 of 4x over x times 1 over 9. So I can take 1 over 9 outside the limits. I think that will make my life easier. Does that make sense? I can take out 1/9 outside. So any constant can be taken outside the limits. That's a very easy thing to do. Now, what is the first trig limit? The first trig limit says limit of sine of x over x. Do we have sine in any points here?
In the tan.
Inside the 10, right? So we're going to do that. So that's going to be sine of 4x over cosine of 4x. Does that make sense? Times 1 over x, would you say? Now for me, that it didn't matter cosine 4x times x on the bottom. Can I switch this two in place? I think I can switch them because they multiply each other. So let's just say 1 over 2 times 3 is equal to 1 over 3 times 2. It's no problem.
Mr. A,
Mm-hmm.
why do you have 2 4x's? Oh, wait, never mind.
Because tangent of 4x is equal to sine of 4x over cosine of 4x. That's an argument. The argument doesn't change. So limits x approach 0 here. So it'll be sine of 4x over x times what? Right. And that's it. Now remember, the problem is occur right here. This is a 4x, but this is not a 4x. You had to make, no, you had to make this 4x, right? Here's the problem here. The problem is this is not 4x. So if it's not 4x, we can make a maneuver. You just multiply here by 4 over 4. Why? Because this 4 can go in here, and this 4 can come back out. Because that's still a constant. Now this 4 can never be out, because that 4 is inside the sign of 4x. That 4 is argument. They cannot take it outside the parenthesis. Never. If you do that, automatically wrong on the test. It didn't matter if you got a right answer. I've seen it before. You got a right answer, you take it out. You're not supposed to take it out. You're supposed to multiply this by 4 over 4. This 4 is going to be outside, so 4 over 9. Limit x approach 0 of sine of 4x over 4x. And that's 1 over cosine of 4x. Do you see that? One of the constant, our numerator can go out. One of the constants is going to combine with x, become 4x. Because now we know this is what? And we know this is what? What is cosine of 0? Matt, what's cosine of 0? 1. So 1 over 1 is what? 1. So all this 2 becomes 1. So my answer is 4 over 9. Mm-hmm.
So then where's the whole?
The whole is occur at 0.
What happened to the cosine?
Cosine 4x, because if you plug in x is 0, it'll be cosine of 0. What is cosine of 0? So I plug in. So almost somebody like some people can like simplify things a lot quicker. Some of you guys, some of people in BC, he's like, I think it's Charlie. Charlie says, so anytime I have cosine, it just doesn't matter anymore. That's pretty much true. Because cosine is going to turn to cosine of 0, and that just becomes 1. Even some denominator, that still become 1. Even on numerator, still 1. So 1 doesn't change the evaluations, right? So all the cosines pretty much insignificant. The only thing matters is the sign.
That's only since
Mm-hmm.
will it,
That's only x approach to 0. Good question.
will it always be x with Trig?
Yeah.
I have asked x approaching something else, and all you gotta do is plug into something else.
Okay.
Because trig limit is only applied when limit x approach 0. I'm gonna give you another case. Seven like this. Oh, sorry, 7x cubed. Sine cube of 2x over 7x cubed. Now, this is the question that they give it to me, at least. I don't know what the question she give out. But this is an interesting one. When I was in your age, I really liked Naruto. Do you guys like Naruto? Has anybody ever seen Naruto before? No. Nobody ever seen Naruto before? There's a guy wearing a headband, he can do shadow clone. I don't know. I don't know how to do shadow clone. How to do shadow clone? Like this? I don't know. Okay, so I love actually I'm not a big fan of Naruto. My my favorite character is the guy that controls the shadows,
Oh,
Shikamaru. That's my favorite character. He's always chill about everything. And my second favorite character is Rock Lee. Rock Lee is pretty badass. Um, he doesn't know any ninjutsu. He only know like fighting style, which is, and he's very stubborn. He's one of my favorite character, and yeah. So this case that I'm gonna say limit x approach 0. Why do I mention Naruto? This remind me of Naruto. This has a 3. That means you're gonna split to 3 different versions of that. So sine of 2x times sine of 2x times sine of 2x. Does that make sense? And this x cubed, can I split x times x times x and just take out 1 over 7 in the front? Your life is a lot easier because all you gotta do is make each one sine 2x over 2x. So I'm gonna multiply 2 over 2 here. I'll multiply 2 over 2 here, and then multiply 2 over 2 here. Now, obviously, this becomes 1. And this becomes 1. And this becomes 1. Now, I just have to take out a 2, 2, 2, which is 8 over 7. Because this 2 can be outside. This 2 can be outside here. And this 2 will be outside because they are multiplying together. It'll be limit x approach 0 of sine of 2x over 2x times sine of 2x over 2x times sine of 2x over 2x. Then this becomes 1, 1, 1. So the answer is 8 over 7. And that's my answer is 8 over 7. Now the thing is you had to make sine x over x happen. A lot of time you can just see a most simplest thing. A lot of people struggle in this part. The homework is already posted on WhatsApp. That's the first part of homework. Second part of homework, I wish that you can do half of them. But second part of homework is going to be the whole review sheet of what happens going to be on the test. But I'm going to start with trig limit because I think for me, it is important. My job is, it's a calculus teacher, not an AP calculus teacher. I don't agree with AP. And yes, I say on the live stream, I don't agree with AP. And I'm an AP teacher, so come after me, College Board. Unless you start doing a better job, then I won't criticize you. So, and what I mean is, I'm not criticizing you is because calculus actually got rid of related rate, optimization, trig limit, definition of integral. They're all super important. And they don't put those in the test anymore. And I think that's only thing matter for future for us engineer is optimization. You have to understand optimization. That's like the most important thing when you started calculus. You want to optimize something, and they don't put that as much those questions on the test anymore. So, yeah. College Board, if I'm talking, you're listening. There we go. So the answer is 8 over 7. So your homework, you can start it. You can help out each other. But that's the first part of homework. Second part of homework, you want to get as much done as possible. If you struggle some of this, just kind of leave it blank and come back and ask each other how to do something. You're going to struggle a lot. What? She hates trig limit and she's in BC.
Work out.
You can start with one question. Start trying. The only way you can try, the answer is included, by the way.
Like it's always a constant. On the second one we did, like it was to the power of 3 and then 2. So we would have done 2 to the third. We would have got I don't know if it's like
You can do that, but just because you can do 2 to the third top and bottom. And then you take out a 7, so 7's gone.
Yeah.
And just multiply 2 to the third and 2 to the third on top and bottom. And it's going to split 2 on each individual x on the bottom. So I just show you a very visual way to do it. But you don't have to show as many steps. But the answer is there. The only thing I will say is this. Do not just take the 2 out. This is bad. The 2 cannot be taken out because the 2 is inside the sign argument. So you cannot take it inside out. It's like taking square root 2x out and take out a 2. That doesn't make sense. The homework answers included. You're going to try your best. You're going to help each other out. Coming after school tutoring. You're going to have a hard time. You're supposed to have a hard time. Those people get it. They get it right away. Those people don't get it. It's going to take a while. But it's not in the AP, but it's in my test.
But like the question we just did, why do you multiply by 2 over 2 in this?
Because 2 over 2 is 1. Because your goal is to make bottom 2x as well. Because you want to sign of 2x over 2x. Sign of 2x over x is not one of the trig limits. It has to be. So Chase, guys, Chase come and ask a good question. Why do I need to make bottom 2? Can it be sign of 2x over x? That's not what a trig limit says. The trig limit says limit x approaches 0 or sign of x over x. It has to be exactly the same thing. So 1x over 1x. But in this case, since it's sine of 2x, I better make sure it's sine of 2x over 2x. So I multiplied top and bottom by 2 over 2. But I merge the bottom, I take out the 2 on the top. Just because it makes easier. So if I see sine of 2x over 2x, that's equal to 1. And then I can take out the 2 on the top, and I just leave the bottom one with a sine of 2x.
And then since it's 2 over 2, it's still multiplied by 1. So
yeah, so you're not changing the fraction.
You know what I'm saying? Sorry. I think 5, right?
How much time we have? It's okay.